Hello and welcome to SudoKanard. We are here to solve this killer Sudoku by German author Christoph Seeliger for the Deutsche Sudoku Meisterschaft, namely the German Sudoku Championship, and it was more specifically the qualifying round. And this puzzle was not one of the top scorers. It was still not one of the lowest scorers. What's spectacular about the setting is the fact that this outer ring is totally devoid of clues. And actually the clues are all just dominoes and they're stacked in a very efficient manner. So let's start solving this. First thing I'm noticing here is that we have two small clues. For each of them there are two possibilities, but if you know the possibilities for 5 are 1 and 4 and 2 and 3, and for 6 they are 2 and 4 and 1 and 5. And the thing you can see here is that 2 and 5 prevent both of those possibilities. If you put 2 and 4 into those cells, there's no possibility for the 5. So this is actually 1 and 5, and this is now 2 and 3. And if you're familiar with 4 cell cages, you must know that 11 with 4 digits can only be made with 1, 2, 3, and 5, which is another way of seeing this. And something similar is happening here, namely that here the only way to have 29 as the sum of 4 digits is with 5, 7, 8, and 9. So 5, 7, 8, and 9, and the only way to dispatch them into those cages is to put 7 and 8 here, and 5 and 9 there. So that's a nice start. Now this 11 won't be 2 and 9, it won't be 3 and 8, it won't be 5 and 6, so it has to be 4 and 7. And there's already a 7 in this column, so the digits are in this order. Now this 7 can't use a 4 nor a 5, so it won't be 4 and 3, it won't be 5 and 2, so it has to be 1 and 6. Perhaps let's look at this. Here we have a total of 35, which means that the remaining 3 digits must have a sum of 10, so 9 is much too big here. That's a 5, that's the 9. And those 2 digits must have a sum of 5. And something very interesting here is that there's nowhere to put digit 9 into those cells, so the 5 here is with 1 and 4. So now we've used 4 in the row and 5, so this 13 is not 4 plus 9, it's not 5 plus 8, it has to be 6 plus 7. And there are 2 options remaining for 11, which are 2 plus 9 and 3 plus 8. This row here still needs 8, 9, and 6. So this 11 here will be with a 5, a 2, or a 3. Now the sum of all 3 digits here, of all 3 cages, sorry, is 34, so the remaining 3 cells must have a sum of 11. That doesn't seem to be so useful. Perhaps I should look somewhere else. Yes, another place to look is this central box. We have 44, that's it, yes, 44 into the cages, so the remaining digit is a 1. There's this ambiguous that. Now looking at this, am I seeing anything? So is this about that, I'm not sure. So oh, sorry, I've been missing this. Those 2 digits must be 2 and 3. That's not so useful, it appears. So where is the next place to look? Oh. I'm feeling a little stuck all of a sudden. Is this about this 13 or this 10? I'm not seeing what I'm missing, which is probably the definition of missing. So let's recall that the digits here should be from 2, 9 and 3, 8. So because of this, that's not a 9, so that's from 3, 2 and 8, and this is from 9, 3 and 8. Is that useful? Perhaps I should focus on those. Perhaps on this 9, because this 9 does not use any of those digits, so it could be 3 and 6, it could also be 4 and 5. But what about 3 and 6? Oh, 3 and 6 would not be possible, because there wouldn't be any option for this 8 cage. I think that's what we are supposed to see, which is not that easy. So to state the things, there are 3 ways of achieving 8 with 2 digits. 7 plus 1 is not available, 6 plus 2 is not available, 3 plus 5 is not available. So 3 and 6 here is not an option, 4 and 5 is necessary. And now this 8 can't use the 5, can't use the 7, it has to be 2 and 6. So now 2 is no more an option here, and 9 is no more an option here, and we get the 2-9 pair in this domino. This 10, I could have seen this earlier. This 10 does not use the 9, it does not use 6 nor 7, so it has to be 2 plus 8. And it disambiguates this and that. This 9 now can't use any of those digits, but it must have an even digit. If you have 2 digits summing to an odd total, one of them must be even, the other must be odd, so it must contain an even digit, and because of this it has to be the 4. So this is 4 plus 5, and the remaining digits in the row are 1, 3, and 7. So this here is 3, 7, or 9. This column still needs 1, 3, and 9. 9 is not here because of this. 9 won't be in the 8 cage, so 9 is here. So this is 1 or 3, but 3 here would put a 7 there, which would clash, so that's the 1. That's a 7. That's a 6, that's a 1. With this 6 and this 9, this is 8. I can remove those 8s, and that's not a 3 anymore. So here I need a 5 somewhere. That's a 2, 3, 5 triple. Here I need 6, 9, and 3. So that's not a 3. And those are not 3s either. So that's a 3 and that's a 2. And here this is now a 3. And this is from 1, 4, and 7. Now, where do we look? This 12 can't have a 7. It can still be 3, 9, or 4, 8. But because of this, we know that there must be a 9 in here. So this is 3 and 9. So that's the 2, that's the 3. And here we need 4 and 8. But 8 there would put a 3 here, which would clash. So that's 4 with the 7, and that's 8. And this 4 disambiguates the 4, 5 pair. This 7 removes 7 from those options, and this is not a 3 anymore. So the 3 on this row has to be here. And because of this 3 and this 3, there must be a 3 somewhere in here, but 3 won't work in this 13. So 3 is here with the 7. That's 1, 4, and 7, and this 4 makes this a 1. This is a 1 just by the rules of Sudoku because of those ones. And here we need a 9 and a 5. There's a 9. There's already a 5 in this column. So this 9 makes this a 3, this a 9. Here I need 4, 6, and 8. Not 8, not 4. This 9, can it be found? It's not 3, 6, it's not 7, 2, it's not 4, 5, so it has to be 1 and 8. This 8 disambiguates that. This 12 can't use the 3, can't use the 8, so it has to be 5 and 7. There's a 5 here. This 7 disambiguates that. So it's a really subtle construction, but you have to go everywhere, to bounce everywhere. This 8 here, this must be 3 and 8. The 6 is outside, so because of this 8, that's 3, that's 8. That's not 3. This 8 now must be 2 plus 6. There's a 6 here, so 2, 6, and this is 4 and 9. This 2 here gives the 8 and the 2. On top, we can place an 8. And this is a 4. This 8 places the 6 down there. That's the 4, that's the 8. This 2 or 9 found its counterpart here, but it's not a 9, so that's a 2. That's the 9 and the 2. So that's now 5 and 6 to make 11. That's a 9. 1 is not here, it's here. This 2 disambiguates the 5-2 pair. We get this 7. Here that's a 4 and a 9. And in this row we get a 4-9 pair. So this is 5-4, this is 6. This 4 here actually disambiguates all of that. So this is a 3, this is a 9, and we finish with 6, 2, and 5. So there was a bit of struggle at some point. The tricky part was really this, seeing that one of the options for 9 prevented this 8 from having any solution. So this was on the tricky side for this kind of rating, I think. But it was really a nice puzzle by Christoph. Thanks for watching this video and see you soon on SudoKanard.